In the previous video, we had a pretty thorough exploration of the fact that the derivative of your vector valued function, that vector gives a vector that is tangent to your to your original vector value function. It's a vector that's moving in the direction of motion. I shouldn't say vector moving, a vector pointing in the direction of motion that you're going in. Well, velocity is the direction that you're moving in. So let me write down here some definitions riffing off of this. If we're thinking of it as a position vector for some particle, for some object moving through space, velocity is the derivative of position. So we can write here that v is equal to dr dt, or equivalently r prime of t. And then once you have velocity, speed is the magnitude of velocity. So speed is equal to the magnitude, the length of the velocity vector once you computed velocity. How do you get to acceleration? Acceleration is the derivative of velocity. So a is dv dt is d squared r dt squared, or equivalently we could say a is v prime of t or r double prime of t. These are all equivalent. And then finally, unit vector in the direction of motion. So velocity is pointing in the direction of motion. How do we turn it into a unit vector? Do the standard, take v and divide by its length, divide by its magnitude. Okay, so these are going to be important definitions for us all throughout chapter 13. Let's do a quick example with these. Find velocity, speed, acceleration for this particular r of t vector valued function here. So I gave r of t. So for velocity, v of t, we just take the derivative here. R is r prime of t. So the derivative 2 cosine t I hat, we're just going to take derivative component by component. So negative 2 sine t I hat. The derivative of 2 sine t would be 2 cosine t. So we have 2 cosine t j hat. And then the derivative of 5 cosine t quantity squared, that ends up as negative 10 times cosine t sine t. That's very easy to do with the chain rule. I'll let you verify it for yourself here. So negative 10 cosine t sine t times k hat. So this is velocity. Let me skip speed for the time being just to very quickly do acceleration. A of t is v prime of t is r double prime of t. So the derivative of this will be negative 2 cosine t I hat minus 2 sine t j hat. And then the derivative of this right here, the derivative of this would be, let's see, negative 10 cosine t times the derivative of sine t would be cosine squared t. And then we'd have negative 10 times sine t times the derivative of cosine t would be negative sine t. So all of that there times k hat. Okay, so we have velocity, we have acceleration. To find speed, we just have to go back to velocity and take the magnitude, take the length of our velocity vector. And so speed will be given by the square root of the first component squared plus the second component squared plus the third component squared. This simplifies down a little bit here. So this would be 4, and let me just write this down here. This is 4 sine squared t. This would be 4 cosine squared t. And so we can combine them together to get 4. And then we'll just leave, we'll just leave this other thing here by itself as 4 plus 100 cosine squared t sine squared t. Okay, so that is finding velocity, speed, acceleration for this particular example here. Let me do one other thing. I didn't write this down here, but just as an example, what is the velocity vector when t is 7 pi over 4? We can find that by simply substituting in 7 pi over 4 into this expression. So negative 2 sine of 7 pi over 4 I hat plus 2 cosine 7 pi over 4 j hat minus 10 cosine of 7 pi over 4 times sine of 7 pi over 4 times k hat. And crunch, 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 crunch. This ends up as square root of 2 I hat plus square root of 2 j hat plus 5 k hat. And the reason I'm doing this example, sometimes I borrow examples straight from the book. Let me just show this off right here on this side. So this is the this curve. It ends up being a loop over and over again. This will be the path of our particle. And right there is when t is equal to 7 pi over 4. And you can see the velocity vector is pointing in the direction that you're moving there at that instant.